This is Mr. Ward, and this is the video key for PreAlgebra exit ticket 25.2. And there's a fancy chicken. Looks like a Muppet. And there is Newton's universal law of gravitation, where G is 6.67 times 10 to the negative 11th. F is the force in newtons. M1 is mass of one object in kilograms. M2 is the mass of a second object in kilograms. And R is the distance between those objects in meters, which is going to get squared in a denominator. So here we have a penguin. So what would the gravitational force between a 2 times 10 to the 0 penguin and a 3 times 10 to the 0 kilogram, the penguin is kilograms, and a 3 times 10 to the 0 kilogram chicken standing 8 times 10 to the 6 meters apart? That's basically standing the chicken around the equator, maybe a little south of it, and the penguin somewhere in Antarctica. Okay, so let's consider our equation. So we need to, in the numerator, say 6.67 times 10 to the negative 11th, that's the gravitational constant, and then we're going to say 2 times 10 to the 0, and then 3 times 10 to the 0, and that's all going to be times 8 times 10 to the 6th power squared, because we got to square that distance. So let's start grouping stuff. These 10 to the 0s we'll be able to probably ignore because that's just ones. So I'm going to group the 6.67 first. 6.67 times 2 times 3. And then I'm going to divide that by 8 squared, because I got to square the 8. And then over here I'll have 10 hours. So it's going to be 10 to the negative 11th. I'll go ahead and add 0 plus 0 just to make sure it's all clear. And then I need to subtract what's in the denominator. So that's going to be minus 6 times 2, because I'm squaring 10 to the 6 down there. Okay, let's figure out what this equals. Grab the whole parentheses, copy pasta, go to calculator, sort that out, and I get 0.6253, blah, blah, blah. So I'm going to round that to 0.625, 0.625, and then over here I'll have 10 to the, let's see, negative 11 plus 0 is just negative 11, and then 6 times 2 is 12, so it's going to be 10 to the negative 11 minus 12, and that'll be 0.625 times 10 to the negative 23rd newtons. Okay, but I need to turn that into scientific notation, so I'm going to move the decimal over 1, makes 0.625 10 times bigger, so 6.25 times 10 to the, since that got bigger, this has to get smaller, 10 to the negative 24th newtons of force. All right, now that number we need to turn into pounds. Get down here and turn it into pounds. To get newtons into pounds, we divide them by 4.45 newtons per pound. So this many newtons divided by 4.45 newtons per pound. Okay, since newtons is in a numerator and a denominator, they will cancel out. Since it's 1 over pounds in a denominator, that comes up to the numerator. So we just need to work out 6.25 divided by 4.45, and that's going to be times 10 to the negative 24th pounds. And let's work out what 6.25 divided by 4.45 is. A little more than 1, so I don't think we'll have to adjust our scientific notation. We get 1.4-ish. So I'm going to call that 1.4 times 10 to the negative 24th pounds of force. And let's simplify this expression here. We've got a W That's to a power, and we've got some j's as well. So I'm going to deal with the w first because that's just one thing. So that's w to the -2. That's not a w. Let's say that again. W to the -2 times -3 power, because between here and here is a power law. And then I've got j to the -4 times -3 power. And then over here, I've got a j to the 7 times j to the 3rd. So I can go ahead and add 7 plus 3 to what I get there. So I'm going to go ahead and use that kind of bracket to group the groupings. Square bracket. Now, let's start simplifying. W to the -2 times -3 is going to be w to the 6th. And j, okay, let's go one step at a time. -4 times -3 is going to be 12. And 7 plus, then it'll be plus 7 plus 3. And so that'll be w to the 6th times j to the 12 plus 10, so to the 22nd power. And you're done. That's the answer. I hope that helps.